Welcome to our introduction to network design, your go-to guide for understanding how to build a smart, scalable, and secure networks. Whether you are new to this or preparing for the Cisco Certified Design Expert written exam, this video will walk you through all the essential. We will cover what good design looks like, how to plan for growth, avoid common mistakes, and build a network that works now and in the future. So let's get started. Network design is more than just connecting devices. It's about planning a network that performs well today, adapts for the future needs, and supports the goals of the organization. Example, a retail business with multiple branches needs a design that allows inventory system to sync in real time across all stores. That's a smart network planning, not just hardware setup. A network is like a blueprint of a building. You don't start construction without a plan. A well-designed network supports business goals. Example, a company that wants to faster customer service needs a network that can handle video calls and real-time messaging apps. Reduce downtime and slow connection. Example, redundant internet links ensure operation continue even one line fails. Scale with business growth. Example, a growing company can add new offices without needing to rebuild the network from scratch because it was designed to scale from a day one. The basic of network design, requirements first. Great design starts by identifying clear requirements. These fall into three key categories. Functional requirements. These define what the network must be capable of doing. Example could be employees should be able to connect to cloud services, use video conferencing, and access resources remotely with secure VPN connection. Technical requirements. These are the specifications that support functional goals. Example could be like the network should deliver at least 1 gigabit speed, maintaining low latency for real-time traffic like voice or video, and use a specific topology such as star or mesh. Application requirements. These are specific needs related to key software or services. Example, a voice over IP system will need low jitter to maintain call quality, while a backup solution may require high bandwidth for the large file transfers. Planning the network design. Before jumping into diagrams or configs, answer the big planning question. What is the scope? Are you designing a brand new network for a new site or upgrading an existing setup? What are the specific goals? Is the goal to support hybrid work or integrate cloud services? What are the constraints? Is there a limited budget or legacy hardware that can't be replaced yet? These answers and questions will shape the design decisions ahead. Greenfield versus Brownfield. There are two common types of design projects. Greenfield design, this involves creating a network from scratch, offering full control and flexibility. Example, designing a new warehouse network with the latest tech, structured cabling, and optimized layout for wireless access. Brownfield design, this involves upgrading or expanding an existing network, often with compatibility in mind. Example could be like adding cloud connectivity to all on-premise network without disturbing existing operation. Use cases for network design. You will encounter many scenarios that call for thoughtful design, adding new technologies, transitioning from local servers to a hybrid cloud model, replacing outdated system, upgrading from a traditional VPN to a more dynamic SD-WAN solution, merging networks. After acquisition, the networks of both companies need to be unified securely and efficiently. Each of these requires its own design strategy and problem-solving approach. Principle of network design. There are 4 core principles that makes any network reliable, secure, and easy to manage. Example, use firewalls, endpoint protection, encryption, and zero trust models to ensure only verified users and devices get access. High availability. The network must remain operational even when parts fail. Use redundant switches, backup internet connection, and automatic failover mechanism to avoid downtime. Scalability. Network should grow with the business without major redesigns. Build infrastructure that allows for quick addition of new departments or branches using modular switches and flexible IP addressing schemes. Simplicity and manageability. Simple networks are easier to manage, monitor, and troubleshoot. Example, use consistent device naming, standardized configuration, and centralized monitoring tools to make life easier for the IT team. Techniques that make it work. Designers use certain techniques to make network more efficient, reliable, and easy to manage. Use separate module for the campus network, for the data center, and for the wide area network or WAN. So each can be managed independently and scaled separately. Organize the network into logical layers for better flow and troubleshooting. Core layers provides fast, high capacity transport across region. Example, a 10 gigabit link connecting major office buildings. Distribution layer connects different departments or subnets. Example, handles routing between marketing and HR networks. Access layer, where end users devices connect. Example, laptops and printers connect here via wired or wireless access. Common mistakes to avoid. Even experienced designers make missteps, and here are few to watch out for. Making assumption. Don't guess. Confirm with real data. Example, don't assume all users need the same bandwidth. A developer uploading a code to the cloud may need more than someone checking emails. Over-designing. Too much complexity increase cost and reduce reliability. Example, a small office with 5 users doesn't need a full enterprise-grade core network. That's an overkill. Ignoring best practices. Best practices exist for a reason. They work. Redundant links and a proper cable labeling are basic but crucial for troubleshooting and reliability. Holding on to outdated ideas. Don't rely solely on static routing when dynamic protocols like BGP can adapt automatically to changes in the network. Scaling the network. Growing business needs a network that grows with it. Example, add VLANs for new departments without impacting existing ones. Use modular switch stacks that can expand as more ports are needed. Plan your IP address space to accommodate new offices or services. Planning for failures. Failures are inevitable, but great design keeps them from becoming disasters. Identify single points of failure. Example, one power supply on a core switch. Add a second to ensure uptime. Use redundancy. 2 internet service providers at your main office allow for automatic switchover if one goes down. Have a recovery plan. Example, if your main data center fails, your system should automatically fail over to a backup site or cloud environment. Network design is the backbone of IT success. A good design is a secure, scalable, simple, and well planned. By understanding requirements, following proven principles, and avoiding common traps, you will create a network that perform reliably today and scale into the future. Thanks for watching. Be sure to like, comment, and subscribe if you found this helpful. And stay tuned for more tech wisdom in the next video. Thank you.